So let's talk about virtual machines. And one thing that you're going to want to know is how a virtual machine works and what is a virtual machine. That's really going to help you in programming Java to understand the concepts that are involved in running your Java source code, running your Java programs. So if you look at this diagram here, you can see that I'm showing several different operating systems. And this could be, you could have Windows, Linux, Mac. You can think of those operating system blocks as those operating systems, or really any operating system. Top of them is a virtual machine. This would be your Java virtual machine for Java. And you can see that each operating system has its own virtual machine. But if you look at the top there, you have your Java source code. It gets compiled by a Java compiler, and that compiled Java code can run on any one of those machines. So basically what's happening here is you're writing your source code once. You're not doing any differences for the different platforms. And there's of course some exceptions to this rule, but the design of this is intended to be such that you write your source code once. In fact, not only do you write it once, but you compile it once. This compiled Java code is actually interpreted. It's like an assembly language for these virtual machines, and the virtual machines are acting to make the same thing work in the different ways that operating systems handle things like files and networking. And so really you're writing your code against these common Java libraries using the Java language, and the virtual machines are handling the differences to produce basically the same output on each operating system. That's the basic idea of a virtual machine, is that it's virtualizing the operating system. It's virtualizing your application so that it can run on any operating system, and it doesn't have to be written specifically for that operating system. And that's kind of really the key advantage of Java. So a little bit more about the JVM. It's basically an abstraction layer. We talked about how the virtual machine, or how a virtual machine basically lets you abstract away or run your application on multiple operating systems and have them run the same way without having to create a different source code or do ifs inside your source code based on the operating system. You could just write your code in one way and target against the Java framework, and that the virtual machines would handle doing that thing, or rendering that view, or rendering file IO or network operation for you in that operating system. So it's an abstraction layer so that when you're programming in Java, when you're thinking in Java, you're thinking about the Java framework and you're not thinking about what operating system it targets. The other important thing about the JVM is that it doesn't run Java source code. It doesn't compile it. The Java source code is compiled ahead of time. It's compiled into .class files, which are basically bytecode. And bytecode is nothing more than really an assembly language for the Java virtual machine. So just like computers, an x86, a Intel PC basically would have its own assembly language, the Java virtual machine has an assembly language, which is the bytecode. And because of this, you can actually run more than just Java in a JVM. There's a whole host of languages that exist now that compile themselves down to Java bytecode and therefore can be run inside of the JVM. So really, this idea of bytecode is abstracting away, helping to abstract away the operating system so that you can run on multiple operating systems, but it's also abstracting away to some degree the programming language. And you'll see a similar thing if you're familiar with .NET. It's a very similar concept, except .NET wasn't really designed to go for different operating systems, but it does allow different languages. The JVM does garbage collecting, and we're not going to go into detail in garbage collection, but garbage collection is basically a way that you don't have to manage memory yourself. And the JVM is really what's allowing this to happen. As your code is being run and you're creating new objects and you're asking for new memory, the garbage collector is running in the background in the JVM where your application is running, and it's determining which things are no longer being used, and it's freeing up that memory for you. So this is a really important concept that a virtual machine provides to you and that the JVM is doing. So if you're familiar with C++ and allocating your own memory and freeing it up, Java frees you from having to do that. And the other thing along with that, by running in a JVM, is you have some safety. It's kind of a sandbox. A JVM is going to do things like verify that the code doesn't violate its memory or address spacing, that it's not going to be able to just access some random part of the operating system. Things that are running inside the JVM are sandbox. They have that safety, because the JVM's enforcing that safety. Whereas if you're running just a native program, there's nothing to stop you from overwriting some memory location that doesn't belong to you, unless the operating system itself has that control. But inside the JVM, you're guaranteeing that safety.